So the question of this exercise is basically dependent or based on the HCF, finding of HCF of two integers. What we are trying to do here is we will try to solve these questions using the Euclid division lemma. Now before I go ahead, what is an HCF and what is LCM, right? So we need to understand it. Let us take the first one first. This is 32, right? So 32, let us divide by 2. 2 16 are 32. 2 8s are 16. 2 4s are 8. 2 2s are 4. So 32 can be written as 2 into 2 into 2 into 2 into 2, right? Now let us take 54 now. I am just trying to explain you the traditional method of finding the HCF, right? So we have 54, so 2, 2 2s are 4, 2 7s are 14, now 3, 3 9s are 27, and we have 3 3s are 9. So now 54 can be written as 2 into 3 into 3 into 3. Now what we do here is, let us make a Venn diagram like this. Okay. What are the common numbers? 2 and 2 are common, so let us write it here. And the other numbers which are not common, let us write it here. 2 into 2 into 2 into 2. And take, this is for 32, this is for 54. Now for 54 it will be 3, because the other numbers which are not common, I am writing it here. So the common number or the common factor 2 and 2, this is the HCF. So HCF of 32 and 54 is 2. And what will be the LCM? LCM will be these all numbers, 2 into 2 into 2 into 2. Then the common one, that is 2 is common between them. Then the leftovers of 54 which were not common, that is 3 into 3 into 3. So this multiply, how you just have to multiply this 32 into 9, 3 is 9, 9 is 27. So 32 into 27 is the LCM, and HCF is 2. Now this 2 we are going to find out throughout this exercise through Euclid lemma. So I'll try to explain you one, and we'll be just taking few of those. So let me take you to the first one. See, HCF of 32 and 54. Now we always know that Euclid lemma says, or Euclid division lemma says, that we can have a number A if it can be represented in the form B into Q plus R, right? Now here we have 32 and 54. So we have to represent 54 in terms of 32. So here A is 54, B is 32. This Q and R we don't know, we have to find out. So let us see how do we find out. So how can we represent 54 is equal to 32 into something plus some remainder? This is quotient, this is remainder, right? Now 32 into, if I multiply it by 2, 32 into 2, it will be 64. So it goes above the 54. So we cannot have 2 here. If I put Q equal to 1, so let me write it as 32 into 1. So it will be 32 into 1, that is 32. But still we have to complete 54. So how do we get this remainder? We just have to subtract 54 with 32. So 54, 32, the difference is 2, and this is, you just have to subtract these two. So 22. So remainder is 22. Now this is done. Okay. 54 can be written in the division lemma form like this. Now how do we find out the HCF? We will continue this again and again till the time we reach a point where the remainder is 0. When we reach the remainder as 0, this number will be the HCF. How? Now 54 can be written as in the division lemma form 32 into 1 plus 22. Now we didn't get any remainder. So 32 has to be represented in the form of 22. Same way, we are again reapplying the division lemma. So 32 has to be written in the form of, 32 is A now, 22 is B now. So how do we write it? How do you represent? Again, if I multiply 22 with 2 or 3, it will go past 32. That we don't want. So we'll multiply it by 1. What do we get? We need to have 10 as the remainder. So 22 into 1 plus 10 is 32, right? Still the remainder is not 0. So now again we'll reapply the division lemma. A will be 22 and B will be 10. So 22 can be represented as 10 into something plus some remainder. Okay. So 10 into say 2, 20, and then 2 is the remainder. Again, we are not getting remainder as 0. Again reapply with the division lemma with A as 10 and B as 2. So 10 can be represented as say 2 into 5 plus 5 2 is a 10. So we get a 0. Now we get a 0 here, that is remainder is 0, and this 2 is the HCF. I hope you got the idea. This is how, by applying the division lemma, we get HCF as this number. Now we will take one more example. Say, let us take the last one, because all of them are same. All of them are same, right? So let me take an example of 100 and 190. Do we have more? No. So let me take an example of 100 and 190. I'll again start with this. Now here we have to see which one is the greater one. 190 is greater than 100. So this has to be A, this has to be B. We are applying the Euclid division lemma. So we have to represent A in the form of B so that B have some quotient and a remainder. This is what division lemma says. So 190 has to be written in the form of 100 into something plus something, so that 190 completes. So 100 into, if I multiply it by 2, it will go beyond, it will be 200, so it go beyond 190, that we don't want. So we'll multiply it by 1, and then what do we get? 90. 100 into 1 is 100 plus 90 is 190. So this is okay. Now here, this is A, this is B, this is your Q, and this is R. So we have a division lemma. But we need to find out the HCF. So we have to go up till that point to actually get R as 0. So now this becomes A and this becomes B. We have to take this. So we have to represent 100 in the form of 90 by division lemma. So 100 we are going to take. 90, again I can multiply only 90 by 1, because if I go beyond 1, that will be going past 100, that we don't want. So 90 into 1 plus 10, right? Again, the remainder is not 0. This is remainder, it is not 0. So what do we get? How do we do? Now this will be A, this will be B. So 90 has to be represented in this 10 form. So 10 into something plus something, Q and R. So if I multiply 10 by 9, I get 90. So that means remainder will be 0. So 10 into 90 is 90. Remainder we got 0. So what do we get? This number is our HCF. 10 is our HCF. So this is how you are going to solve this first question, means different parts of first question. Let us take one more, same thing we have to apply, and I'll tell you about these three. We have later questions. How do we find out the HCF of three numbers? So the basic point is finding out the HCF is, say 184 is there. I'll not solve it. I'll take you to other questions, because we have special questions for these 3 or 4 numbers, finding out the HCF of 3 or 4 numbers. You have known about the traditional method, which I told you first. Now I am going to tell you about the Euclid lemma. So what do we do here? 184 is there, 230 is there, and 276. I'm just taking an example of one of the part. What we have to do here is we will apply the Euclid lemma in order to find HCF of this. Say HCF of this is x. Now this x, the HCF of this, we'll take it as x, and now x and 276. We need to find out HCF of these two. So this will be the final HCF. I hope you got the idea. We'll take the questions. So this is the finding of HCF. I'm just letting you know the answers. That is, this is how we have to do. I'll take one of these, say this one. Okay. So let us take this one, 867 and 255. We have already done this, but just need to practice more. Now here, what first thing which we have to do here is 86. I'm taking this one. Others you can please take. You can just solve by yourself. The idea which I'm trying to explain. I'm taking one more. So 867 and 225. First, what we have to find out, 867 and 225 are two numbers, and we have to find out the HCF. How do we do this? The first thing first is we have to find which one is the greater than. So 867 is greater than 225. So this will be A, this will be B. Now we have to present it in the form of A is equal to BQ plus R. This is division lemma. Okay. And this R lies between, there is a value which lies, this R has to lie between 0 and certain value, which is one of these. Okay. It cannot go beyond that. But we are trying to find out the HCF at that point where remainder becomes 0. This B is going to be our HCF. So let us start. 867 has to be represented in the form of this 225 I am writing in the place of B, and I don't know what to multiply. Let us multiply it by 3, because if I multiply by 4, it goes past 867 that we don't want. So 225 into 3, and if you are not aware what to do, what has to be taken here, you just subtract 867 with 225 into 3. So you get a 192. Now you don't have a remainder as 0. So 225 and 192. Now this is A, this is B. So 225 can be written as 192 into 1, because if I multiply it by any other number, it will go past 225 that we don't want, plus 33, right? Now after this, what do we do? Again, we are not getting remainder as 0. So 192 and 33. So 192 is equal to 33 into some number, say 5. That will be, and you just subtract 192 with 33 into 5, you get 27. Again, we are not getting remainder as 0. So 33 has to be written as 27 into 1, and subtract 33 and 27, you get a 6. Right? Now A is this, B is this, remainder is not 0. So 27 has to be represented in the form of 6. 6 4s are 24 plus 3. Again, no remainder, so 6 and 3. So 6 has to be written in the form of 3 into 3 to the 6. So we get a 0 here. The point you get a 0, this number, as I said, this B, this is B. This B, 3 is the HCF. So HCF of 867 and 255 is 3. So this is how we solve it. So now HCF we have to find out of, this is the third question, of following pairs of integer and express it as a linear combination of them. So here we will be backtracking. Backtracking means we are going to find out the HCF, then the steps have to be followed backwards in order to represent in the form of linear combination. I'll tell you how to do this. We'll take an example of 963 and this, say, 657. Okay. So I'll just show you here how this is done. Then I'll explain you how to write them in the form of linear combination. So 963 and 657, which one is bigger? 963, of course. So 963 can be written as 657 into 1 plus 306. This is your A, this is your B, this is your Q, this is your R. So this is we are following the Euclid's division lemma. 963 can be written as 657 into 1 plus 306, because 306 is not a zero remainder. So 657 and 306 has to be taken as A and B. So 657 can be written as 306 into 2 plus 45. Again, remainder is not 0. So we have to follow the same thing with 306 and 45. So 306 is equal to 45 into 6 plus 36. Again, we have to take these two because remainder is not 0. 45 is equal to 36 into 1 plus 9. Right? So now again remainder is not 0. So 36 and 9 we have to be taken. 36 is equal to 9 4 is 36. So we are getting 36 here with the remainder 0. So as I said, this 9 will be equal to your HCF. Now this you have already learned by now. But how to write this in the form of linear combination? So I'll start with 9. You just see how I backtrack. All these steps I have to backtrack like this till I reach this point. How to do this? See, the HCF is 9. So how do I write 9? 9 is equal to, see, 9, how this 9 has came? 9 has came from 45 minus 36, right? 45 minus 36. So we can write it as 45 minus 36. I'm just backtracking. 9 has come when we subtracted 45 and 36, because 45 we represented as 36 into 1 plus 9. So 9 is essentially equal to 45 minus 36. So this is 45 minus 36, right? Now let us say it as into 1, because this 36 into 1 is, we have to write this proper one, 36 into 1. Now for this 45, this is 45 minus. Now see, how did we come at that point where we are saying this 36 might have come? This 36 has come from 305 minus 45 into 6, right? So in the place of 36 we will write 306 minus 45 into 6, because 306 minus 45 into 6 is 36. This is what we got from here. So I'm just backtracking. Other thing remains the same, right? Let us expand these. 45 minus 306 into 1, and minus minus is plus, so plus 45 into 6 into 1. So 45 into 6 into 1. So this is 45, this is 45 into 6. So this becomes 45 into 7, right? This is 45 into 7 minus 306 into 1. Up till this point it is okay. But you see, where does this 45 has come? 45 has come from 657 minus 306 into 2. So I'll write in place of 45, I'll write 657 minus 306 into 2 into 7 minus 306 into 1. Now let me expand this. This becomes 657 into 7 minus 360 into 2 into 7 minus 306 into 1. So this is 657, 306 into 306 into 2 into 7 is 14. So this is minus 360 into 14. This is minus 306. Sorry, this is 306. 306. So 306 into 14 minus 306 into 1. So this becomes 14 and 1 is, because both are minus, so we'll just add them. 306 into 15. Here we have 657 into 7. Right? Because of the lag of the space, I'll just explain you here. Now here, this up till this point we have reached. But how this 306 has come? How this 306 has come? 306 has come from here. It is nothing but 963 minus 65 into 1. No, 657 into 1. So in this place 306 will write 963 minus 657 into 1. So 963 minus 657 into 1. Expand it. 963 into 15, this one, and 657 into 1 into 15, like this. Now we have 657 here, we have 657 here, we have 15 and we have 7. So 15 and 7, just add them. You get 657 into 22. 657 into 22. We have taken this and this added, minus 963 into 15. So this is your final linear combination. I hope you got the idea. We just backtracked and we finally wrote 9 in the form of this by backtracking, like this. So I hope you will be able to solve these three. These are the solutions for you. I just encourage you to solve by yourself. These are all the same way. Let me take this example, okay, so that we complete this. So 1288 and 575. 1288 has to be written in the form of 575. So 575 into 2 plus 138. Remainder is not 0. Euclid lemma will apply with 575 and 138. 575 can be written as 138 into 4 plus 23. Again, no remainder. So we'll take 138 and 23. 138 can be written as 23 into 6 and we get a 0. So 23 is HCF. Now 23 can be written as what? 23 can be written as 575. 23. How do we get 23? It is simply 575 minus 138 into 4. So 575 minus 138 into 4 is 23. Now how do we get this 138? 138 we got by 1288 minus 575 into 2. So in the place of 138 we'll write this. In the place of 138 we are writing 1288 minus 574 into 2. This 4 remains outside. Now let us just expand it. 575 minus 1288 into 4 minus minus is plus 575 into 8. So this is what we get, and we can just because one more step can be done. This is 575 into 1 and this is 575 into 8. So we can just write it as 575 into 9 minus 1288 into 4. This is the final form. Find the largest number which divides 615 and 963, leaving remainder 6 in each case. The question is that there is a number, say x. So if I divide this by x, I get a remainder as 6. If I divide 963 by x, I get a remainder as 6. So how to find this x? There is one more theory here, that if I subtract 6 from 615, this x is going to divide it fully. If I subtract 6 from 963, I will get a proper 0 when I divide 963 minus 6 by x. Exactly this what we are going to do here is, we'll take 615, subtract 6 from here, we get the 609. We'll take 963, subtract a 6 from here, we get 957. Now these are the two numbers. When they are divided with a certain number, this number x is going to divide both of them. So that means we are trying to find out the HCF. So we'll try to find out the HCF of 609 and 957. So now HCF of 609 and 957 will apply the Euclid division lemma. How to find the Euclid division lemma? 957 is greater, so we'll write 957 in the form of 609. So 957 will be 609 into 1 plus 348. Okay. Now these two we have to take because remainder is not 0. 609 can be written as 348 into 1 plus 261. Again, we didn't get the 0, so we'll reapply this Euclid with 348 and 261. 348 is equal to 261. This is 261, I guess. 348, 261. Yeah, it's 261. So now 261 and 87, again we have to reapply. So 261 becomes 87 into 3, we get a 0 here. So 87 is the HCF. So 87 is that x. This is the number which will divide 615 subtracted by 6 and 963 subtracted by 6 totally, fully. If the HCF of 408 and 1032 is accessible, or you can say you can express is in the equation form, 1032m minus 408 into 5, we have to find m. So it becomes quite easy here. We just have to find out the HCF of these two numbers, and when we find out the HCF of this number, say it is x, so we'll just equate it with 1032 minus 408 into 5. This is what we have to do. So now we are aware how to find out the HCF. We'll just quickly jump into finding the HCF. We know that 1032 and 408, which is the higher number, 1032. So 1032 will be represented as 408 into some number plus some number. That is the division lemma. So 1032 is 408 into 2 plus 216. We go till the time we get an HCF as means the remainder as 0. So we get an HCF. So 408 can be written as 216 plus some remainder. 216 and 192 will take. 216 will be equal to 192 into 1 plus 24. No remainder 0. Then we'll reapply 192 and 24. So 192 is 24 into 8. We get a 0. So 24 is our HCF. As I said, we'll just equate 24 with 1032 minus 408 into 5. So when we solve this, we get m equal to 2. Let me solve it for you. 24 is equal to 1032m minus 408 into 5. 408 into 5 is 2040. Now take this 2040 this side. So you get 24 minus plus 2040 equal to 1032m. 24 plus 2040 is 2064. 1032m. Now take 1032 in the denominator. So m is what? 2. So m is 2 here. Same thing, if the HCF of these two numbers is expressible in the form of this, we have to find out x. So we'll try to find out the HCF of 657 and 963 using division lemma, and then we just equate it with this number. So here, I hope that you'll be able to find out by this method. 9 will be your HCF, so you just have to equate 9 with 657x plus 963x minus 15, and we have to solve for x, and this is the solution. X will be your 22. An army contingent of 616 members is to march behind an army band of 32 members in a parade. So there is a band and there is an army contingent. Now what is happening here is the two groups are in the same number of columns. So this, say, we just have to equate them. So if there are, say, 3 columns here, it has to be 3 columns here. If there are 30 columns here, it has to be 30 columns here. So what is the maximum number of columns in which they can march? So essentially we have to find out the highest common factor in terms of this lanes, or you can say columns. So we'll take 616 and 32, find out the HCF. So 616 and 32, let us find out the HCF using the Euclid lemma. 616 can be written as 32 into 19 plus 8. Now we'll take 32 and 8. So 32 can be written as 8 into 4. So we get a 0. 8 is our HCF. So we have maximum number of columns or the lanes as 8 in which they can march. A merchant has 120 liters of oil of one kind, 180 liters of another, 240 liters of third kind. He wants to sell the oil by filling the 3 kinds of oil in tins of equal capacity. So these are 3 cans or 3 tins of equal capacity. What should be the greatest capacity of such a tin? So when it comes greatest, that means it is highest. Highest is nothing but highest, common. Common means these 3 are there and we need to have a common value and factor which pertains to all these 3. So we have to find out the HCF of these 3. So how do we find out the HCF of these 3? First of all, say 3 different oils are there, 120, 180 and 240. So let us take 120 and 180. 120 and 180, which one is the bigger? 180 is the bigger. So 180 can be represented as 120 into 1 plus 60. So now the remainder is not 0. So we'll take again 120 and 60. 120 is simply 60 into 2 plus 0. So this 60 is the HCF of 120 and 80. Now what do? We have already got the HCF of these two numbers. So we'll take this HCF and 240. And then we'll try to find out the HCF of these two numbers. That will be the final HCF or the capacity of the tank or tin. So 240 can be represented as 60 into 4 plus 0. So we get a 0 at the very first time. So 60 is our divisor. So this is 60. 60 is the HCF. This tin should be, or each tin should be of 60 liters. During a sale, color pencils were being sold in a pack of 24 each and crayons in the pack of 32 each. So 24 each color pencils and 32 each crayons. Say pencils and crayons. If you want full packs of both and the same number of pencils and crayons, how many of each would you need to buy? So what we are trying to do here is, we are trying to fix them in one so that equal number of pencils and these crayons can be there. So here we are trying to find out the LCM. Okay. So what is the LCM of 24 and 32? Let me tell you how to do this. 24 and 32. The simple method is like this. Just take these two and start dividing. 2, 12 and 2, 16. Then 2, 2 6 are 12, 2 8 are 16. Now let us apply 2 again. 2 3 are 6, 2 4 are 8, and then 2. So 2 2 are 4, 3 remains here. So 2 into 2 into 2 into 2 into 3 into 2, which is this one. So 96 is our LCM. This is how you just have to multiply all these numbers, you get an LCM. So now 96 is the LCM. The least number of both colors that needs to be purchased or that can be purchased is 97. Now how to find out the number of packs of pencil to be bought? You just divide 96 with what is the number here? 24. Divide by 24. So you get a number of packs of pencils as 4. How to find out the packs for crayons? 96 is the LCM. Divided by 32. So you get as 3. So 3 are the number of packs of crayons. 144 cartons of Coke cans and 90 cartons of Pepsi cans are to be stacked in a canteen. So we have 144 Coke cans and 90 as Pepsi cans. They are stacked in a canteen. If each stack is of the same height and is to contain cartons of same drink, what would be the greatest number of cartons each stack would have? Now the question is asking about the greatest number, that is it is asking about the highest, and there are two different entities, two different numbers. So we need to find out the common one on this, because we have to stack it on the shelf. So we have to find out the HCF of 144 and 90. So 144 and 90 is there, you just find out the HCF. You know by now how to find out the HCF using Euclid lemma. This HCF will be 18. This is the greatest number of cartons in one stack, will be 18.